Hello. Right, knockers and butts. And I'm not losing my marbles, this is strictly a technology video. Nicknames for a piece of test equipment. That's a reasonably well matched pair of knockers. And that is a butt. Linesmans test telephone. The name comes from originally being nicknamed a butt-in or butt-in telephone because you could clip it on an active line to see if it was in use or actually listen to a conversation if you were so minded. And the knockers are so called because when they're active, turn that on and turn the amplifier on. Do that, which you may have heard on telephone lines at some point. There used to be some numbers in the UK that if you dialed them by either knowing them or by accident, that's all they did. You could just hear that test tone. But the main reason for these, or the main usage, is cable tracing or pair tracing, depending what receiver they use with. Turn that off because it's annoying. These produce quite a high level signal with a lot of harmonics in it, and with the right receiver or amplifier, it's only audio, but with the right amplifier, they can actually be used even for tracing underground cables. The output is that strong with that many harmonics, and the amplifiers used with that are so sensitive. Now, these are only the built-in probe amplifiers, so these are only used for fairly short range work. But as you can see, it's quite sensitive to anywhere near, even though that's that twisted pair, it's not spread out to form an antenna. Like I'm now holding that as far away as I can reach, and it's still picking up the signal from that. They are very sensitive. The original earlier ones, that's an earlier one that can work with all sorts of probes. I mean, the basic probe is just which I don't have, unfortunately, is just a piece of wire with a bit of a handle on it on the screen and the centre tip exposed, so it works more or less the same as that. But you can also use other kinds of pickup and other connections for longer distances, including underground cable tracing. And again, this works. It's quite an interesting thing. Oh, another bit of trivia. Notice that's an amplifier 109. This is the BT version of one of those amplifiers, which doesn't work. Notice it's also an amplifier 109. About 50 years apart. They just keep increasing the suffix on the things as they develop new versions. And the same with the actual knocker, the oscillator, which is which? That's an 87. That's an 87. Again, yeah, it's like 40, 50 years apart. And that also works. I can figure out what I did with the... thought I brought the rest of the stuff through for that, but it seems... oh, I have. Sorry. Right. Now, the older ones use the old-style GPO jack plugs, which are weird things, a larger diameter than normal jack plugs and multi-way. You can still actually buy them from certain places. And that's the linesman's headset, or the engineer's headset, just a one earpiece and a band. The signal is quite loud if put it on test. It's got to have something plugged in to turn it on. And of course, you just try to do a video, it doesn't work. Oh, there we go. Oh, it's not working on the monitor. But, oh, I do know. I bet it's got to have a load on it. And it's because there's nothing on the end of that wire. Yeah. Yeah, it needs a load on the main output for the headphone to work on the monitor. But that's also got variable output. As the newer types only got to slow or fast. If you're using them on multiple cables at the same time, you could set different speeds to allow different cables to be identified. And that also works in here. The power switch is by plugging the headphone in as well, or the earpiece in. Now this is because this is one of the very early ones. It uses a belly and lead socket, which is the old type UK TV aero connector. I don't have a cable plug, but that's a panel plug, but you can see the style. And again, I'm holding the casing, so grounding myself with it, so it's not very sensitive with that. But it works fine. They're interesting construction. I keep getting sidetracked with things, but they're just worth seeing the construction of this. Little dust fastener to take the lid off. They're supposed to have a 4.5 volt battery in the old style cycle lamp battery that's got two long brass leaves coming out of it. You poke into there, but they're expensive and difficult to get now. Whereas AAs are common, so I've just got a 3 AA cell in it. But the whole circuit is encapsulated except for the transistors, which are slotted in afterwards, so the transistors can be replaced on the basis that they probably rightly assume that they're the only thing that's likely to fail or degrade. So it is designed to be serviceable even though it's mostly encapsulated. And the same with the oscillator. Snap that back together and open this one up. That's hidden away in the top, but the same thing. It's a big encapsulated block with the transistors just recessed in holes and soldered afterwards. And the same battery setup. It's supposed to be the 4.5 volt cell. Now, but basically that's a fairly modern type butt. Somewhere I've got a vintage rubber butt as well, but I couldn't put my hands on it at the moment. It's a 1960s, one of the earlier types. I found a photo one on eBay. It's much simpler because back then it was only pulse dialing. So basically it's got an earpiece, a microphone, probably an internal transformer to match them. The little red button on the side is a press button with a turn latch to put it online. And when that's not pressed in, it's monitoring only. There's no line current drawn, but you can hear what's on the line to check if it's vacant or not. And it's got a pulse dial. It's a more or less standard rotary dial, as used in all the old British phones. This one's an electronic version, so it's got pulse dialing or tone dialing. I can't do much without it actually connected to something. You can see it powers up. One thing it can do, there's another bit of vintage equipment here. This is around 100 years old. It would go with some of the early telephone equipment, either at the side of a phone or in an exchange. And it's a ringing machine. Let's take the locking screw out so you can see inside it. And basically it's an alternator. Now the lid is damaged, one of the hinges is broken. It's a very open design alternator. So you got the light right. Hopefully you can just about see. Should have a torch. You can just see in there the windings on the rotor. See the coils. It's only 2-pole. Get the light right for it to show up a bit. Now you can see the windings there. Yeah, you can see there the windings around the whole armature or rotor, end to end. And rather than slip rings or brushes, as such, in a conventional sense, one end of the winding is connected to the frame, and the other end comes out through. Again, it's very difficult to see. I might add extra photos. Basically, it comes out through a hollow shaft at this end, and there's a spring-loaded arm down there. You can just see the top of the arm that rides on a contact on the end of the shaft. So that's how it passes through. And there's quite an ingenious little ramp kind of cam on the shaft. So as soon as you start to turn it, those contacts change over to disconnect what's connected to the line locally, so you don't, when you own equipment or deafen yourself with the ringing voltage coming through a earpiece. If I connect that up to butt, so that's connected to that. Not got a connection, or it's there we go. Now that's producing around 50-60 volts AC at about, if you're winding it fairly fast like that, it's probably, I think, somewhere around 20-25 hertz. And before electronic ring generators, an operator would use something like that, or it'll be a motor-driven generator that produced the voltage to ring a bell. I think actually that's probably about it. Oh no, right, yeah, showing you the knockers, and so they're high-level signal generators, so not much good for fine proximity work or locating stuff at close range. This, on the other hand, is a pair tracer. Now this one, rather than producing the high-level pulses, produces a rather lower-level warble, which is very distinctive and easy to pick out from background noise. The idea of that is, if you connect it to a single line, let's get that out of the way, in a multi-pair cable, for example, I'll use that one, use red-green. This is a 10-pair cable. I've stripped it and twisted the pair ends because they're twisted very slow. The twist is only like one full turn or so every 6 inches or something like that on this. And if you leave it loose, they can easily unravel back to the jacket on a short piece like this. And I'm having to strip it again to figure out which pair's which. So if I put the oscillator on that, I've not actually tested this yet, as you see. I didn't even strip the cable. Let's see what happens. See if we can pick out the pair that that's connected to. That's just the that one, talking about Toad, that was just one unravelled. I think I'm playing it still turned on. Right. Yeah, the people that came up with the colour code for this only used 5 colours for each wire. The first digit has 5 colours, the second digit has 5 colours. So the first 5 start with white, the second 5 start with red, and I can't remember the others offhand. But then the sequence for each primary colour is blue, orange, green, brown, slate. Anyway, so actually there's a difference there. Oh, this is variable gain as well, rather than only a 2-level gain like the other style. This is continuously variable gain, so you can take it down from next to nothing to very high gain. Notice there's no, because it's a balanced pair, there's a bit of leakage over it, there's not much difference. If you go to the pair outer, unless you find where one wire is closer than the other. It shows you the balancing effect of the twisted pair. You get it where the two are exactly equal and all out. You get it to where one's far closer to the probe than the other. You go to one wire, and it's very obvious which pair it is. This is also a set of carrying my normal toolbox because it's very, very useful for tracing cables in machines where they're all the same colour. And you've not got a diagram or the wire has been damaged. You can find which wire in hundreds within quite a short time just by running along. Because it's so sensitive a distance, you can just run around a set of wires and pick out a particular one very easily. I mean, that's because it's on. I'm using that as pairs. If you're using it to trace single wires, you ground one or leave it floating, even depending on how strong a signal it's producing and how much is going through the cable. And we get sidetracked very easily. Oh yes, that's it. There's one more interesting bit. Notice how sensitive these things are. I don't know. I haven't actually tried that with that. Yeah, that's it. Similar to maximum sensitivity. On the other one, you can send it deaf. No, it's too tough again. Sorry, that's short one. That's bit lower sensitivity. That's done without any electrical connection at all to the probe. I've got another of these. Last thing I showed you the casing, the BT branded one. And that's had some water damage. I got the pair on eBay as non-working, and it turns out the loudspeaker, or the earpiece, whatever you call it, is open circuit. And there's 1 or 2 spots of corrosion which were cleaned up. Notice that end, there's a track goes into it, under that heat shrink sleeve. What to do with the tip of the thing? Oh, oops, I've forgotten that. Well, it's black on black and I can't see it all. I didn't bring it. Oh, it's there. Right. That's the tip. When it's assembled, that's there. So the end of that little circuit board goes almost up to that step where the O-ring is. The tip there's a bit of glue in there that held it in, rubber glue, but that stops short there. The coupling is purely capacitive between the actual probe and the circuit board, which means it's very, very bomb-proof and immune to accidental contact with high voltages, static discharges, even mains or whatever, because there's just no electrical connection. There's a very, very low capacitance there into a very, very high impedance amplifier. You can actually see that's a an LM393. That's one I couldn't make out. I couldn't find a number. Well, there is a number on it. Can't see it with the camera, but it's one I didn't recognise. I couldn't find on Google. That's a little PIC microprocessor that controls it. And then there's another amplifier set up there. And that little connector connects to a pair of pins in the casing and to a socket in the back for an external earpiece. So it's quite a neat design. You can see there's a lot of options, a lot of spare component positions all over it. So there's probably other versions of these. And as a bit of curiosity, one of the things I noticed, if you look inside it, that looks familiar. And the socket on that, the Bellingly, it looks almost as if they were allowing for another version of the Bellingly socket. It would take old style probes. Now, could be pure coincidence. Now on this, all there is a locator goes into it, but with all the other reinforcement and stuff, I don't think that's actually essential to its operation. 2 screws holding it in place. So I'm guessing there may have been an option for a design that had a socket on there. Anyway, that's a load of telephone and telecoms trivia, which I hope was a bit of interest. And as always, any questions, queries, suggestions, please put them in the comments.